Hey, sports fans. We are almost at the weekend, end of the first quarter. Nearly there. It's exciting stuff. Um, Quick note your tests should be in the gradebook today. And then you guys can check those out. That'll kind of be what your grade is going to look like. And yeah, so good stuff there, hopefully. A lot of them were really good. So hopefully that's your guys's, right? Today we are going to talk about linear functions. So we learned what a function was yesterday. And hopefully you remember that means that there are only unique x's, right? And typically, when we talk about a linear function, all of our stuff in slope-intercept form is 100% a linear function. So when I tell you y equals 5x minus 6, that's a linear function, right? No matter what, I would never plug in the same x value, get a different y value. That doesn't make any sense. So if I was making a table, I'd plug in 1, I'd get, what, 5 times 1 is 5, minus 6 is negative 1. 1, negative 1. If I plug in 2, 10 minus 6 is 4. If I plug in 3, 15 minus 6 is 9, right? I'm always going to get a different x when I pick it, because no x would go with the same y. That doesn't make any sense. So, there's two things that I want to really talk about. Function notation and what that looks like. And then I think I'll do one of those ones where you get a table and we'll talk about how that's a linear function through there. So function notation, okay? This is one of those weird things that they just throw in because I don't know why. When I say something like a line is y equals 2x plus 1. All right, function notation is basically saying, hey, this thing is a function, so I'm going to write it a little differently. Instead of using y, I'm going to use something like f of x equals 2x plus 1. All right, because this thing is a function of x. I could use f of x, or you'll see g of x, or h of x, or all that kind of weird stuff. It's the same thing. All right, there is nothing different from y equals 2x plus 1 to f of x equals 2x plus 1. It's just another way to write something. But what you will see is that they will write it with this in function form, and then they'll say something like, what is f of 5 equal to? All right, whenever they give you something, an f, a function of 5, all that means is you're going to take 5, or whatever number they give you, and we're going to plug it in everywhere we see an x on this right side. So if I'm talking about f of 5, all that means is I'm going to take the x, and I'm going to plug in 5 right there. So f of 5, 2 times 5 is 10, plus 1 is just 11. That's how I'm going to find f of 5. I plug in 5 where I saw x, and I get f of 5 equals 11. Which is basically just saying, which is basically just saying that when I plug this in, the point 5, 11 is on my function somewhere. All right? Let me give you another one. Let's say this time I gave you g of x equals negative 4x minus 3. All right, and this time, so we have, again, that's the same thing as saying y equals negative 4x minus 3. The exact same thing. So if you wanted to graph it, you graph it the same way. Starts at negative 3, goes down 4 over 1, down 4 over 1. But I might say, what is g of negative 3? And if I did so, then you, boys and girls, are going to take negative 3 and you're going to plug it in for x. So you're going to have negative 4. We're going to plug in negative 3 minus 3. Negative 4 times negative 3 is positive 12. Plus negative 3 or minus 3 is going to give me 9. And so g of negative 3 is 9. Ta-da! I hope that you're picking that up. I think that's pretty easy. They give you some equation. They tell you what's h of 17. You just plug 17 in. That's all you got to do. If they want you to graph it, you're going to graph it the exact same way. Nothing's changing. It's just like it says y equals. They're just going to give you some weird g of x, h of x, f of x. That's it. They're going to use function notation a lot. Was like even through Algebra II, through pre-calc, I mean all that stuff. So that's one of those things you're just going to get used to and just be like, it's just y in your head, okay? All right, so then they might say, here is a function and we have some numbers in here. Like so. All right, so I have this function of a table. All the x's are different. And I want to know what this function would look like in function notation. So basically, take the table, give me an equation of the table out of that. Well, there's a couple things you could do. I know if I want to write an equation in slope-intercept form, which is basically what function notation is, right? Then I need, well, it can be, whatever. I need two things. I need a slope, I need a y-intercept, if this is linear. So I can just check my table, if you want to do it that way, and kind of see what's going on. So, or I could pick 2 points. I mean, I'm not sure. I mean, I'm going to tell you right now, this is a linear function. But if you didn't know that, you would definitely want to check to see if it was linear before you did anything, too much work. And to see if it's linear, I just want to see, does it have a constant rate of change? So, for example, how do you get from 17 to 13? Well, you're probably saying you go down 4. How do you get to negative 3 to 2? Or negative 3 to negative 2? Well, you go up 1. So the slope between those 2 points is negative 4 over 1. And then I could keep doing that and see, does it have a constant rate? Well, 13 to 1, that's down 12. Negative 2 to 1 is plus 3. That's negative 12 over 3, which, if you simplify it, is just negative 4 over 1. So it looks like it's probably going to have a constant rate of change. So what I think the easiest way to do this is, I'm going to kind of show you 2 things. The first one is, if it tells you it's a linear function, you can just pick 2 points and do it like we've already been doing it. So maybe I'll pick 1, 1 seems pretty easy, and I'll do 3, negative 7. So I'm going to use my slope formula. y2 minus y1 over x2 minus x1. That's going to give me negative 8 over 2, which is just my slope, negative 4, which we already found from the table. Yes, I know that. So that's one way we can do that. We can pick the 2 points, or we can just look at the table and see how it's changing. And then, remember, we can pick 1 point, use slope-intercept form, and I can plug in my slope, plug in my point. Negative 4 times 1 is negative 4. Add 4 to both sides. Can you guys see down there? Yeah. And b is going to equal 5. So your equation would be y equals negative 4x plus 5. And again, we said function notation, so we're just going to change that to f of x equals negative 4x plus 5. All right, I could do that. What I could also do is kind of use the idea of function notation right away. So rewind with me a little bit. We just looked at the change in the table up here, and we saw that it was always negative 4 over 1, right? So what you're telling me is that f of x equals negative 4x, and we don't know what b is. Well, another option we can do is if we find the slope in the table, which we can do easily, right? Just look for that change, the constant rate of change. What I can do is I'm just going to use a point, so this time I'll use negative 317. That's already an x and a y. So I know that f of, so we already have an x and a y here, right? And so what we can do, if I wanted to just use function notation, is I could say that f of 1, or I'm sorry, if I plug in negative 3 over here into x, that is the same thing as 17 over here for y, right? That's just a point that's on my line. So I'm just using my points. Sorry, my camera keeps falling today. So if I plug in negative 3 for x and I plug in 17 for y, 4 times negative 3 is negative 12. Oh, I'm sorry, negative 4, my bad, times negative 3 is positive 12. I knew something was wrong there. And then I can subtract 12 from both sides. And you can see that that is another way I could get my y-intercept as 5. So it really doesn't matter. I like to just kind of use the first way because we already learned about slope-intercept form and everything, and then I can just throw the function notation on it, and that's easy to work with. I feel like that might have been confusing. Hopefully it wasn't too bad. I just know the first day that my teacher showed me function notation, I was like, what in the world are we doing? And then I figured out it was literally just the same thing as saying y equals, and nothing is changing. So don't get freaked out. It'll be really easy once you start doing these and just plugging them in. All right? Yeah. If you have questions, obviously, let me know. I can help you out. And this homework tonight is the first homework for the next quarter. I know it's a little early, but I don't want to just jam it onto this quarter. Cut everything off. So, do your homework and you'll start with an A+. All right? Cool. If you guys have questions, seriously, let me know and I can help you out. We'll see you later.